Okay, this is lesson 8.3, and we're going to be talking about trigonometry. So when we finish the lesson, we want to be able to use sine, cosine, and tangent ratios to determine side lengths and angle measurements in right triangles. Okay, so the first thing we're going to do is start the lesson off with some vocabulary. Trigonometric ratio. So what is that? So trigonometric ratios are the ratios of corresponding sides of similar right triangles. And we have sine, cosine, and tangent. So the ratios of corresponding sides of similar right triangles. And we're going to be talking about sine, cosine, and tangent. So let's take a look at the trigonometric ratios. So if we want the sine of angle A, the sine of angle A is the ratio of the opposite leg over the hypotenuse. So in this case, it would be A over C. The cosine is the length of the adjacent leg to angle A. So which one is next to angle A? Well, B and C, but C is called the hypotenuse. So this one is going to be B over hypotenuse. So B over C. And tangent is the length of the leg. Let's see, the tangent of angle A is the length of the leg opposite over the leg that's adjacent. So that's going to be A over B. So you can sit down and memorize this, but there is a way that you can remember. So all you have to do is remember so, ka, toa. So when my teacher taught me, she was Princess Sokotoa. So how does that help you? Well, S is sine is opposite over hypotenuse. Ka is cosine is equal to adjacent over hypotenuse. And T, toa, tangent is equal to opposite over adjacent. So whenever you're struggling to remember the trigonometric ratios, just think of Princess Sokotoa. Okay, so in this problem, we're going to write the sine, cosine, and tangent of the ratios for angle T. So the first thing I'm going to do is I'm going to write down Sokotoa. So, ka, toa. Okay, so the sine of T, so sine is opposite over hypotenuse, so it's 8 over 17. Okay, so now let's look at cosine of T. So the cosine is adjacent over hypotenuse, so that's going to be 15 over 17. Now how do I know that 17 is on the hypotenuse? My hypotenuse is always across from the right angle. So angle R is my right angle. So I know that segment TG is my hypotenuse. So let's see. So that's going to be 15 over 17. Now tangent is opposite over adjacent. So tangent of angle T is 8 over 15. And you can do the same thing with G and R. Okay, so before we do the next problem, to kind of help you avoid a lot of frustration, I have an emulator to show you how to set your calculator when you're doing sine, cosine, and tangent. So you'll notice right here, if you have a graphing calculator, we've got sine, cosine, and tangent. And in the blue letters right above, it says sine, and it's got a -1, cosine, and it has a -1, and tangent, and it has a -1. So that's going to be where you get the inverse function. So for all the blue ones, you'll hit second first, and then you will hit that for when we get to the part where you need that. But first, we have something even more important. So when we talk about the trig ratios and using sine, cosine, and tangent, there are two things that you can use. You can use degrees or radians. So I just hit mode on the scientific calculator, and over here is a larger screen. So I'm going to hit my down arrow, and notice that it has radians is the one that's highlighted. We want it to be in degrees. So we're going to have it where it's flashing on degrees, and then we are going to hit enter, and then we are done. So if you happen to have the TI-30XS, so on your screen, it'll say RAD, DEG, or GRA, I believe. So right now it is on radians for our units. So we're going to go over here to mode, and then we're going to, first one is degrees, so it's degrees, radians, and gradians. So we are going to hit enter to get it to switch to degrees. And now you see it has switched to degrees. It didn't take my first one. So that's going to be your first way to check that. And so now we're going to go and take a look at the screen for the TI-30X2. Okay, now this one is super easy to change. So you see this little button, DRG? So what you do is you hit that, and when you do, it's going to have degrees, radians, and gradians. And so you hit that, and then you arrow over. And it is typically set at its default setting is degrees. And this one's probably the easiest to change. So anyway, so that's how you do that. And you always, if your numbers aren't coming out right, you always want to double check that you've got you're set to degrees or radians if you happen to be using radians. Okay, so now we're back to the math. So after that very long aside, so we want to use trig ratios to find a distance. So let's read the problem and see what distance we're looking for. So in 1990, the Leaning Tower of Pisa was closed to the public due to safety concerns. The tower was reopened in 2001 after a 10-year project to reduce its tilt from vertical. Engineers' efforts were successful and resulted in a tilt of 5 degrees, reduced from 5.5 degrees. So suppose someone drops an object from the tower at a height of 150 feet. How far from the base of the tower will the object land? Round to the nearest foot. Okay, so we're looking if somebody's up here and they drop it down 150 feet, how far from the base is it going to be? Now notice where your right angle is on this one. It is not next to the building like it typically is. It is at our line, at the drop line for whatever of the object. Okay, so our 5 degrees is right here. So this is going to be the angle we're working with. So I have this line right here, the 150 degrees. So which line is that? Which part of the triangle? Okay, so this is going to be the adjacent. So I have the adjacent. Now, which one am I looking for? So I'm looking for this one, right? I want to see how far it falls from the base. So with this angle, what would this be called? Opposite. So I'm looking for the opposite. Now, adjacent and opposite. Let's write down our stuff. So, ka, toa. Which one of these deal with opposite and adjacent? Tangent. So in this case, I actually have a number. So I'm going to say that the tangent of 5 degrees is equal to opposite. Well, I don't know what that is, so I'm going to call it x, over the adjacent, which is 150. So now I'm going to solve for x. So I have 150 times the tangent of 5 degrees is equal to x. And so now you plug this into your calculator. This is why it was so important to make sure that we had the right number or the right setting from degrees or radians. So you plug in 150 times, and you hit the tangent key, and then you hit 5, and then you close those parentheses, and you get a scary looking decimal. So we get x is equal to 13.123229953. But it wants us to round our answer to the nearest foot. So x is approximately 13 feet. So now let's take a look at another one. Okay, this is going to be our last example. So this has a key piece of information in it though. So if we know the sine, cosine, or tangent of an angle, we can use the inverse to find the measure of the angle. So wait a second, what does that mean? So if I want to know the measure of angle x to the nearest degree, so I look and I see, and what do I have? I have opposite and I have hypotenuse. So first, so ka, toa, let me go ahead and write that out. Okay, so I have opposite and I have hypotenuse. So I know that the sine of x is equal to 6/10. So the measure of my angle x, so my measure of angle x is equal to the inverse of 6/10. So this is something that you'll plug into your calculator. So, and it's typically going to be a second function. So what we're going to do is we're going to hit second and then the sign key. I'm just going to open up the parentheses and then you're going to hit 6 divided by 10, close parentheses. And when I plug this in, I get, let's see, the measure of angle x is equal to 36.86989765. But it wants it to the nearest degree, so x is approximately equal to 37 degrees. So let's try it on problem B. Okay, so this time, remember we're looking at angle x, and from x perspective, we have adjacent and we have hypotenuse. So which one of these is it? Okay, so it's going to be the cosine. So the cosine of angle x is equal to adjacent over hypotenuse. Now I want to undo that. I want to work backwards. So remember, like the opposite of addition is subtraction. The opposite of multiplication is division. So we're going to do the opposite of this one. So it just looks different. So we've got the measure of angle x is equal to the inverse of cosine of 15 divided by 20. And when we plug this into our calculator, remember we're going to hit the second cosine and then 15 divided by 20, close parentheses, and we get 41.40962211. But it wants it to the nearest degree, so that's going to be the measure of angle x is 40 degrees. I'm sorry, 41 degrees.